Hey guys, here's your guys's your practice or extra practice with graphing rational functions, okay? Just so that you guys can check your work. So, you guys worked on this in the class today. So, um make sure you guys check your work and make sure you guys got everything correct and you guys practice, right? So, to get y-intercept, you guys, you set x equals to 0. So, everywhere we see an x, it becomes a 0. So you get 0 plus 1, 0 squared plus 5 times 0 plus 4, which is basically just 1/4. So we got 0 comma 1/4. Horizontal asymptote, because the numerator is less than denominator, the horizontal asymptote is y equals 0. Don't got a slant. And let's factor everything to see if we have any holes. So if you guys factor that by doing the x method, you guys would realize that the x plus 1s cancel. So x plus 1 divided by x plus 1, you guys, that just leaves 1 up top all over x plus 4. So for whole, you set what you canceled equals to 0. And we have the x value is -1. And then we plug that in, you guys, into the reduced equation. So we're going to get 1 over -1 plus 4, which is 1/3. So our whole is -1 comma 1/3. Vertical asymptote, set the denominator equals to 0. So x plus 4 equals 0. We solve, x equals -4. And lastly, x-intercept, you guys set the numerator equals to 0. But 1 equals 0, you guys, that is not possible. So that means that one's none. Now when you graph this all, so 0, 0 comma 1/4 is just right there, just a little bit above the line, y equals 0, x-axis. Horizontal asymptote at y is equals to 0, so there's a dotted line at y equals 0. Slant asymptote's done. Our whole is at -1 comma 1/3, so -1 comma 1/3, so it's somewhere like that. X equals -4 is our vertical asymptote, which is going to be right here at x equals -4. And we don't have x-intercept. So to graph this, you guys, well, we got these 2 points right here. Can't go through the hole. And then we need a test point because we already have something on the right-hand side of the vertical asymptote. Now we need something on the left-hand side of the vertical asymptote. So I can plug in any of these points. I'll just plug in when x equals -5 and plug it into here to get your guys's test point. 1 over -1, which is -1. So we got -5 comma -1, which you guys, it's right here. So then I know that our graph is going to look like that. Okay, so there's your guys's first graph. Here, y-intercept. So again, set x equals to 0, you guys. So ultimately, when you guys plug in 0 for all the x's, you're only going to get 0 all over 3, which is 0. So 0 comma 0 is your guys' y-intercept. Horizontal asymptote, because the degrees are the same, top and bottom, you look at the coefficients. 3 over 1, which is 3. Slant is none, because we already have a horizontal. Now let's factor to see if we have any holes. So we can factor out a 3x from both, and we could do x method on the bottom to get x plus 3 times x plus 1. These cancel, so here's our reduced equation, right? So for whole, set what we canceled, which was x plus 1 equals to 0. X equals -1. Now plug this in into there to get your guys' y value. We get -3 all over 2. So our whole is -1 comma -3 halves. Vertical asymptote, set the denominator of our reduced equation equals to 0, which is just going to be x equals -3. And for x-intercept, set the numerator equals to 0. So it's 3x equals 0. Divide both by 3, x is equals to 0. Coordinate, 0, 0. So we got x-intercept and y-intercept at 0, 0. Horizontal asymptote is at y equals 3, so go to 3 on the y-axis and draw a horizontal line there. No hole. Oh, there is a hole. Excuse me. There is a hole, which is at -1 comma 3 halves. So it's right there, but it's a hole, everybody. And then we have a vertical asymptote at x equals -3. So go to the x value of -3 and draw a vertical line there. So -1 comma -3 halves. I forgot, you guys, this hole has to be -3 halves, so it's actually down there. Okay, so we can graph this part, you guys. Now the problem is we need to find a test point on this side of the graph, on the left-hand side of the vertical asymptote, because we don't even have a point on that side of the vertical asymptote, right? So I'm just going to plug in x equals -4 into my reduced equation. Three times -4 and -4 plus 3, which is -12 over -1, which is 12. So -4 comma 12, which is somewhere up there. And then you guys, our graph is going to look something like that. So there's your guys' answer in the graph for number 2. Number 3. Okay, y-intercept, set x equals to 0. So f of 0 equals pretty much -4 over -2, which is 2. So 0, comma 2. Horizontal asymptote. Now, this is numerator is greater than denominator, so horizontal asymptote is none. But this leaves the door open to find a slant, right? And the degree up top is 1 degree higher than the bottom, so we are going to graph this. What times x is 2x squared? That's 2x, and then you guys do distribution. 2x squared minus 4x. Now we subtract the top from the bottom, so these are 0. 2, okay, -4, you guys. Negative times a -4x, that's positive 4x, so 2x plus 4x, that's 6x. Drop down the -4, and then x times what, 6x, that's 6. And that's what we're looking for, a linear equation for the slant, right? Okay, so whole, so let's factor this. So we can factor out a 2, you guys, to get x squared plus x minus 2 all over x minus 2. So we can factor this using your guys' x method. So -2 plus 1, 2, -1. So up top, it's really going to be 2 times x plus 2 times x minus 1 all over x minus 2. Nothing cancels, so there's no whole. Vertical asymptote, look at the denominator, so it's x equals 2. X-intercept, look at the numerator, you guys, and x would have to equals to -2. So -2 comma 0 and 1 comma 0 for this one and this one, right? You disregard the 2 because it is on the outside of the parentheses, which doesn't affect your guys' x-intercepts. And then we graph everything. So 0, 2. Slant asymptote, start at 6, and then up to right 1, up to right 1, and also down to left 1, down to left 1. Holes, none. Vertical asymptotes at x equals 2, you guys. So here's x equals 2. And then we draw a vertical line there. Negative 2, 0, and 1, 0. So we can clearly see that your guys' graph is right here. Now we need a test point on the right hand side of the vertical asymptote. So we could do 3 when x equals 3. Now plug in 3 everywhere in the reduced equation, right? And we get 3 times 5, no, 2 times 5 times 2 all over 1, which is just 20. So 3, 20 is our test point. So 3, 20, it seems to be somewhere up there. So that means that asymptote, or that graph, would look like that. And then lastly, you guys, number 4. Y-intercept set x equals to 0. So we're going to get negative 6 over negative 1, which is just 6. So 0, 6. Horizontal asymptote, numerator is greater than denominator, so that's going to be none. We do have a slant because it's 1 degree. The numerator is 1 degree higher than the denominator, which exposes yourself to possibly getting a slant. So x minus 1 goes into x squared minus x minus 6. X times x will give you guys x squared. And you guys subtract this, and these cancel, and these cancel, which is just negative 6. And x can't go into negative 6, you guys, so our slant asymptote is just y is equals to x. Okay, let's see if we have holes. So factor this using x method, x minus 3 times x plus 2, all over x minus 1. Nothing cancels, so no holes. Vertical asymptote, set the denominator equal to 0, so x equals 1. X-intercepts, set these equals to 0, and you're going to get negative 3, 0, and negative 2, 0. So let's graph 0, 6, right? Negative 3, negative 2, 0. Y equals x. So you guys do have to start at 0 and, up 1, right 1. Up 1, right 1, right. Vertical asymptote, x is equals to 1. And x-intercept is at oh, we already graphed those. Oh, so we already graphed all of these. Okay, that's great. So, wait a second. I knew I did something wrong. This negative 3, you guys, should be 3, 0. My bad. So, we don't need test points, you guys, because I already know we have to graph here using the points, and I know we have to graph here using the test point. But that's basically it for graphing, you guys. So good luck studying this and try your guys' best, okay? Peace.